Hello and welcome to Mrs. Law's class. In this lesson, we're going to take a look at some basic probability questions, including the concept of mutually exclusive events. Now, when learning about probability, different scenarios are often used. So these include using one die or a pair of dice, a standard deck of cards, a spinner, or a fair coin, meaning that one side is heads and the other side is tails. We'll consider a standard die to be 6 faces, numbered 1 to 6, like this. In a standard deck of cards, there are 52 cards and they are divided into 4 suits, 13 of each. So we have the clubs, we have the spades, we have the hearts, and we have the diamonds. So notice that 2 of the suits are black and 2 of the suits are red. The suits are numbered from ace all the way to king, and we call these ones at the very end, the jack, the queen, and the king, these ones are called our face cards. So let's take a look at some examples. So in this first one here, we have state the probability of drawing these cards from a standard deck of 52 playing cards. So the first one we want is the 3 of diamonds. So there's actually only one 3 of diamonds, it's right here. So there's 1, and we know that there are 52 cards, so that would be 1 out of 52. All right, the next one is we want a red card. So we know that there's 13 of each suit. So we can say that there's 26 out of 52 cards, or we also know that half of the cards are red, since the other half of the cards are black. All right, we do not want a spade card. So since there are 13 spade cards, 39 of them are not spade cards. So that would be 39 out of 52. Or we can also say that 3/4 of them are not a spade. All right, and lastly, a black queen. So there are only 2 black queens. We have the club and the spade. So 2 out of the 52 cards are black queens. And that's 1 out of 26. All right, let's take a look at another example. Here we have a spinner, and I want you to find the probability of each outcome. So the first one is just spinning, and we want to get a 7. So we have these numbered, and we also have some colors on the outside. If you want, you can color them to make it easier for yourself. So getting a 7, there's 1 out of 8. Now we're going to assume that all of these pie pieces are the same because they look the same. The next one, a 5 or an 8. So we want a 5 or an 8. There are 2 of them out of 8 numbers, so that would be a quarter. All right, the next one is the color red. So we have red here, and red here. So 3 of them, pie pieces, out of the 8 are red. Now the next one we want is an even red number. So here we can see that out of these 3, we have 2 and the 4. So this is even and red. So there's only 2 out of a total of the 8 pie pieces that are red. So 1/4. All right, the last one is we want an odd number on green. So there's only one green number, but we notice that the number is an even number, it's 6. So actually there are 0 odd numbers on green. So 0 out of 8 or 0. We're next going to take a look at mutually exclusive events. So 2 events are said to be mutually exclusive when they do not share common outcomes. Let me show you what this means by looking at some examples. So classify the events in each experiment as mutually exclusive or not mutually exclusive. So let's say that I'm rolling a die. So the first event is rolling an even number, and the second event is rolling a prime number. So are these mutually exclusive? Well, we know that we can have an even number 2, which is even, but it is also a prime number. So 2 is even and prime. So because of that, then this means that this is not mutually exclusive events. All right, let's take a look at the next one. So tossing a coin. The first event is tossing a head, and the second is tossing a tail. Now, assuming that this is a fair coin, there is no way that we can have both a head and a tail at the same time. So cannot have both heads and tails at the same time. So therefore, this is mutually exclusive. All right, last one. So let's say that we're choosing a card. The first event is that the card is a heart, and the second event is the card is an ace. Well, we do know from our cards that there is an ace of hearts. So because there's an ace of hearts, therefore, these events are not mutually exclusive. Now, for two mutually exclusive events, the probability that either of them will occur is equal to the sum of the probabilities that each of them will occur. So that means we can add each of the probabilities together. So for example, what is the probability that when you roll a die, you will get a 4 or a 5? So we're going to write this out formally. So the probability of a 4 or the probability of 5 means that we can find the probability of 4 plus getting a probability of 5 when we roll a die. Excuse me. So the probability of a 4 on our standard 6-sided die is 1/6, plus the probability of getting a 5 is also 1/6. So this gives us 2/6, which is equal to 1/3. Now, for two non-mutually exclusive events, after adding the probability that either of them will occur, you need to subtract any events which are common to both. So for example, what is the probability that when you roll a die, you will get an even number or a prime number? So we can say that the probability of even or probability of prime number is equal to the probability of an even number plus the probability of prime number. However, there is an even prime, so we have to minus anything that is even and prime. So the probability of an even number, there are 3 even numbers on a die. So we know that they are 2, 4, and 6. And then for the prime numbers are 2, 3, and 5. So there are also 3 prime numbers. Now we know that 2 occurred twice. So therefore we need to subtract 1/6 because the 2 is both even and prime. So therefore what we get is 5 out of 6. Now this might seem a little bit long considering we can just count them, but when we get to more difficult questions, you'll have to be using a formula similar to this to find the answer. All right, let's take a look at an example. So given the spinner, find the probability of each outcome. So the first one is the probability of red or blue. So we have 3 that are red and we have 2 that are blue. So these are actually mutually exclusive events. I'm going to write ME. So therefore, we can just count all of them and say that, well, actually, you know what? We'll do this properly. So there are 3/8 that are red plus 2/8 that are blue. So that gives us 5/8. All right, the next one is red or odd. So again, we know that there are 3 that are red. And then the odd numbers are 1, 2, 3, 4. Odd numbers. But we can also see that one of the odd numbers is also red. So we need to subtract 1/8. So this will give us 6/8 or 3/4. All right, the last question is the probability that the spinner will give us a yellow number or even. So there are 2 yellows. So it's 2 out of 8. And we know that half of the numbers, 4 out of 8, are even. Now, are there any yellow and even numbers? Yes, there is. There's one right over here. So we need to subtract 1/8. So that will give us 5/8. Now, like I said before, yes, we can just count them, but we want to just be able to use this formula as well so that we can extend it to more difficult questions later on. The last type of question I want to take a look at are called independent events. So 2 or more events are independent events. When one event does not affect the other event. So for example, picking a card from a standard deck of cards and then rolling a die. One does not affect the other one. So we can write a rule to find the probability for 2 independent events. So let's say the probability of event A occurring is the probability of A, P of A. Say the probability of event B occurring is P of B. Then the probability that both A and B occur is written as the probability of A and B. You might also see a set notation that looks like this, A with an upside down U and B. So if A and B are independent, meaning that one does not affect the other one, so A and B, then we get this rule that we can take the probability of A and multiply it by the probability of B. And this formula can be extended to 3 or more independent events. So let me show you with an example. So find the probability of tossing a head on a coin and rolling a 5 on a 6-sided die. So we're going to use a tree diagram to verify our answer. So according to our formula, the probability of a head, probability of a head on a coin and getting 5 on a 6-sided die is equal to the probability of head times the probability of getting a 5. So probably getting a head on a coin is a half, and then probably getting a 5 on a 6-sided die is 1/6. So that's going to give us 1/12. Now, if I draw a tree diagram, if I toss a coin, I can get head or tails. Now, after getting the head, we're now going to roll our die, and there are 6 possible outcomes because we can get 1, 2, 3, 4, 5, or 6 on the die. If the first toss of the coin is a tail, again, we can also have 6 other outcomes of the die. So 1, 2, 3, 4, 5, or 6. And we see that we want a head on a coin and a 5. Only one of these branches, this one here, gives us what we're looking for. So that's one possibility out of 12 altogether. So that will be 1/12. So the tree also shows you how we can get the answer. But of course, we don't want to draw the tree all the time, and that's why we have a formula.